SwayamPrabha. Digital India. Educated India.
Welcome back. Today we will talk about NIOSH lifting equation. National Institute of Occupational Safety and Health, they have given a description about what is the recommended weight limit when you are doing the lowering or any lifting job. So we will be talking about recommended weight limit and the lifting index. So let us begin with the process and some description about this particular tool. This is very much useful tool when we are talking about manual material handling in a particular scenario. Specifically when we are in a manufacturing unit or in a load carriage section or somewhere where load handling is important by human, not with the automated system. Okay, so those cases this particular tool is very much important. It talk about the what is the recommended weight limit for a person to work in certain duration, for a certain duration, so that his or her back is not going to get any kind of injury. So you can continue this for your shift. Okay, so that type of calculation you will be doing depending on the vertical height, depending on the kind of movement they are doing, depending on the kind of posture the person is holding. Based on that, this particular tool will give you the value of recommended weight limit, which you can do the lifting and lowering. So no pulling or pushing, it talks about only lifting and lowering. So we call it, so initially it was NIOSH lifting equation, but in 2000 after some certain years it has been again revised, and finally the final revision has came on very recently, and that is 2021, and it is called revised NIOSH lifting equation. It is revised version of the NIOSH lifting equation, which is published originally in 1994. with improvised tables and images along with some typographical corrections. Okay, so there were some small errors, those things they have corrected. Focused towards researchers and field safety professionals in improving the work risk assessments for manual lifting job. So as I mentioned, it only talks about manual lifting and lowering job. It is again recognized by professional ergonomists in the United States and many other English speaking countries. Now here concern is why we are talking about English speaking countries, because initially it was derived those areas in Western countries. Now it is being accepted by all other places, okay, but there are some limitations when you are translating it. That is why it says mainly for all English speaking countries this tool is well accepted. Even in India we use this particular tool for our lifting calculation, okay. It can assess right and left sides of the body independently as well as any worst case. So, you do it right separately and left separately, or you can do whichever is the extreme bad. So, you can take any one of them. It provides a guidelines for a more diverse range of lifting tasks used in meat packing, small part assembly, keyboarding and any other highly repeated hand motions with lifting. Okay, so those cases we can use this particular tool. Now let us understand, when we are talking about lifting job or manual lifting task, how do we define it and what are the varieties of factors that we are going to consider while doing or reading this particular tool. So let us start with the definition of lifting task. So, it is defined as the act of manually grasping an object. So, you are holding the particular object manually of definable size and mass. So, the size and mass need to be defined with two hands and vertically moving the object without any mechanical assistance. So, that is why I said whenever the lowering or lifting task is without any automation. Okay. So, such job where you are using your both hand, you are grasping the object or the weight with your both hand and you are doing the vertical lifting from one place to another height or from one place to another height. So, only vertical lifting. Okay. So, that is the lifting task we will be considering for this particular equation. Any other task apart from this definition we will not be able to consider for NIOSH lifting equation. So, before you go for this particular tool, use of this particular tool, what you need to do? You need to check that your task that you are going to or you are planning to assess is matching the definition of this lifting task or not. Once it match, then only you can go ahead with using of NIOSH lifting equation. Now, let us take the important variables or name of the factors which we are going to measure and we are going to get the value of recommended weight limit. The first value is load weight. So, weight of the object to be lifted either in pound or in kilogram including the container. So, if something is there in a container, with that container what is the total weight of the object, that you have to measure and you have to tell that that is the load weight for NIOSH lifting equation and you can only measure with either with pound or in kilogram. Next important variable or factor is vertical travel distance. Vertical travel distance. So, absolute, so here it is very important, okay, for lifting and lowering. So, whatever the vertical distance travel, so that is why it's absolute value, no plus or minus. Okay. So, absolute value of the difference between the vertical heights at the destination and the origin of the lift in inches or in centimeter. So, we have FPS unit and SI unit in place. Okay. So, that is why it is saying the absolute value of the difference between the vertical heights and at the destination and the origin. So, probably origin is here and destination is here. So, in that case this only the value that you are going to get, or if it is the origin and this is the destination, that means it is lowering from here, it is coming down. Okay. So, that only that particular number, that particular absolute value. So, that is the vertical travel distance. Next point is neutral body position. So it is described the position of the body when the hands are directly in front of the body and there is minimal twisting at legs, torso and shoulder. So you are standing straight and your both hands is in front of your body. So that is the neutral body position. So that means your body is aligned in your body midline. You are not twisting on either side, not in the left side or right side, neither your shoulder nor your torso nor your legs. Okay, so all are in symmetrically as aligned with your body midline. So that we will be calling it as the neutral body position. That is the reference point, and from there we will be measuring the deviation or asymmetry angle that I am coming in the next slides. Okay. Then horizontal location. We talked about vertical distance travel. Now we are talking about horizontal location and vertical location. So first let us understand the horizontal location. So distance of the hands away from the midpoint between the angle in inches or centimeter, measures at the origin and the destination of the lift. So you can understand. So this is your body midline. So this is one point of your ankle. This is one point of your ankle. So this is the midpoint of your ankle, and here is the position of your hand. So your horizontal location is this. Okay, this is your horizontal location. So distance of hands away from the midpoint between the ankle. So if you have two ankles positioned here, so midpoint is here, and what is the position of your hand. Okay, so distance from here to here. So first you have to identify where your ankles are located and where is your hand is located. So first you find out the position of your ankle, then get the midpoint, and from there you measure the distance of your hand. So okay, so that is your horizontal location. Next point is vertical location. So distance of hands above the floor in inches, distance of hands above the floor. So from if this is your floor and this is your hand position, so this is your vertical location. Okay, this is your vertical location. It's very important. Okay, so while doing the measurement, sometimes we get very much confused between these values. So you have to be very careful. So this is horizontal location and this is vertical location. Fine, clear? Let's move to the next point. Now is the asymmetry angle. We understood what is our neutral position. So on a sagittal plane, if we are moving, then what is the angle formulation? So first let us read it out. So angular measure of how far the object is displaced from the front, that mid sagittal plane of the worker's body at the beginning or ending of the lift in degrees. Okay, measures at the origin and the destination of lift, so minus it. The asymmetry angle is defined by the location of the load relative to the worker's mid sagittal plane rather than the position of the feet or extent of body twist. So that way you are doing. So here you, from this particular figure, you can understand this is your body midline and the person has been moved from, this is the destination, like this and this, right? So it is moving from this to this. So what is happening? This is your sagittal line, this is your sagittal line. So first you have to draw the sagittal line, and one direction the person is moving. So and this is your asymmetry line. Okay, so this is the angle is being formed by your body, and we will be calling it as asymmetry angle. So point is, first is very important for you to identify the neutral position, so that you can understand what is your sagittal line, and then sagittal, on the sagittal plane what is your body midline, and from there which angle it is getting formed. Okay, so then you measure that angle. Okay, and then you do the correct value of the angular measurement. It is decided in degree. Okay, you measure it in degree. So from this type of figure you can refer, and you can get the value of your asymmetry angle. So it's a kind of cylinder, right? When human being is standing in a place, it's a kind of cylinder. You have sagittal plane, you have frontal plane. Okay, so you just look at your sagittal midline, sagittal plane line, and then you see what is the angular movement you are forming in which direction. Only that value you take as the asymmetry angle. Now coming to the next few important variables. First is lifting frequency. So average number of lifts per minute over a 15 minutes period. Here it is very important. You have to take the recording for 15 minutes, then you have to convert that value into lift per minute. It's not that you check that per minute how many lifts are happening. First you have to record it for 15 minutes, and from that particular 15 minutes data you have to convert it into per minute data. Okay, so average number of lifts per minute over a 15 minutes period. So that is the lifting frequency. Coming to the next variable, lifting duration. So three-tiered classification of lifting duration specified by the distribution of work time and recovery time. So we call it as work pattern. So duration is classified as either short, that means 1 hour job, moderate 1 to 2 hours, or long 2 to 8 hours, depending on the work pattern. So that way, so three major classification: short, moderate and long. Short is 1 hour, moderate is 1 to 2 hours, long is 2 to 8 hours. Okay, so you have lifting duration. Next variable is coupling classification. Now coupling is very, very important. Why? If your coupling is not good when you are handling any load, that means if it is not good, then you are using lot of strength or extra strength from your body of the same weight. Suppose it's a 5 kg weight. If coupling is good, then you have less strain on your body, whereas if coupling is not good, it is definitely more than that whatever you were exerting. So coupling identification for any load handling, as we discussed in MSc, you have you definitely can refer that in MSc manual handling chart. In that case you identified that how the coupling is important. If coupling is bad, then whole activity you may not continue for longer hours. So here also in NIOSH lifting equation, coupling is a very important impacting factor. So what is the coupling? The classification of the quality of hand to object coupling, that is the handle, cutout or grip. So coupling can be classified as 3: good, fair and poor. Now here, as I mentioned, that it's it's descriptive, it's subjective, right? So there are definitions. So from that you can know from your experience, you can go for good, fair and poor. Okay. Now significant control. What is the kind of control you have in that particular job? So significant control is defined as a condition requiring precision placement of the load at the destination of the lift. This is usually case when the worker has to re-grasp the load near the destination of the lift, or the worker has to momentarily hold the object at the destination, or the worker has to carefully position or guide the load at the destination. Suppose you have a load in your you are holding a particular load, and positioning is very important. You are looking at the thing, so checking and inspecting and positioning. Such cases, or worker has to re-grasp it. You have to you are holding, then again you are holding it properly, maybe sleeping or something. So those cases. So what is the kind of control you have on the load? So you have to have such kind of identification while doing this particular assessment. Now, recommended weight limit that we are going to get after this whole classification or whole evaluation. So, let us understand that particular terminology. So, recommended weight limit is the principal product of the revised NIOSH lifting equation. The RWL, or recommended weight limit, is defined for a specific set of task condition as the weight of the load that nearly all healthy workers, very important, nearly all healthy workers could perform over a substantial period of time. For example, it is expected, always the work shift is for 8 hours, so it is expected that they will be able to continue it for 8 hours without an increased risk of developing lifting related any low back pain. So, NIOSH lifting equation actually assess the risk of lower back pain or low back pain. So, what this RWL is, this definition is very important. Okay, this definition is, if you don't understand this definition, then you will not understand what is the value of this particular tool. So, RW, recommended weight limit, right? So, recommended weight limit is defined for a specific set of tasks. It's not for everything. The task that you are going to analyze, for that specific set of task condition, so other conditions are specified as the weight of the load that nearly all healthy workers could perform over a substantial period of time without an increased risk of developing lifting related work low back pain. Maybe low back pain can come from any other reason, but for this lifting there will be no low back pain. That is the recommended weight limit. So, it is based on the multiplicative model model that provides the weighing of each of the 6 task variables that we are going to discuss, and the weighing are expressed as coefficient that serve to decrease the load weight to be lifted under ideal condition. Okay, so that is the recommended weight limit, and this is the formula that we are going to get the recommended weight limit, the value of the recommended weight limit. So, before we go for this calculation, let us we almost studied few of these variables. We will see how do we calculate these variables. So, these are the factors. First is the load constant. So, we have the load constant, then we have H as the horizontal location multiplier, HM. V denotes the vertical location of the object relative to the floor, and it will give the vertical multiplier. D, distance the object is moved vertically, so vertical distance travel, so that is the vertical distance travel multiplier, that is dm. asymmetry angle multiplier, AM, frequency and duration of lifting activity, that is the frequency multiplier, and final one is the coupling factor, and it gives the coupling multiplier. Okay. So, and if we multiply all these factors, we will get the recommended weight limit for a certain task in a certain condition. So, this is very important. Okay. Now, these are the if you are using metric unit, these are the values. So, load constant is 23 kg or 51 pound. Okay. And these are the formula you can use for horizontal multiplier, vertical multiplier, distance multiplier, asymmetry multiplier, frequency multiplier and coupling multiplier. Also we have some pre-computed table, from there also we can get the calculation or the multiplier value. Either you calculate using these formulas, okay, these formula you can use for the calculation, or from a pre-computed table you can get the value. So, I will take you for each multiplier separately now. So, each multiplier can be computed from the appropriate formula, and in some cases it will be necessary to use linear interpolation to determine the value. If the measured frequency is not a whole number, the appropriate multiplier must be interpolated between the frequency value in the table that are closest to the actual frequency. Once we get recommended weight limit, then we can convert it to get an understanding that is this load is correct or not. We will calculate the lifting index. What is the actual load right now in situation we are handling, divided by the recommended weight limit. Okay. So, if it is more than 1, definitely there is a risk. If it is near less than 1 or equal to 1, then it is normal risk, there is not a problem much. So, what is lifting index? The lifting index is a term that provides a relative estimation of the level of physical stress associated with a particular manual lifting task. The estimate of the level of physical stress is defined by the relationship of the weight of the load lifted and the recommended weight limits. So, lifting index we denote is as Li. Li is equal to L divided by RWL. L divided by RWL. Okay. So, that is the lifting index. Suppose for example, your recommended weight limit is 45 kg for a particular job, and right now your current load weight is, suppose I am talking 90 kg. Okay. Then your lifting index is equal to 90 divided by 45, that means 2. So, 2 is greater than 1, that means it is extremely dangerous. This has very high risk. Whereas, if your load instead of this 9, if it is somewhere around 22 kg or 20 kg or something, then your lifting index becomes 20 divided by 45, definitely it is less than 1, right. So, then it is nominal risk, fine. So, this way you can calculate the lifting index. So, what is the procedure? So, first is the observation of the task and selecting the task which you are going to assess, determine the task variables which is required, determine and record the task variable values, calculate the RWL and lifting index and derive the required inference. So, if lifting index is more than 1, definitely you need to do some kind of intervention, design changes, or work shift, some changes you need to do so that lifting index comes down. So, that is the way how we use NIOSH lifting equation for any kind of ergonomics intervention. So, let us take each component separately now. Till now, I hope you understood whatever we have discussed about this particular thing. Now, we will be talking about each component separately. So, horizontal location that denotes as H is this this demarcation like H, V, D, these are constant. Okay, you cannot change it according to your wish. These names are very important demarcations. Okay, so horizontal location is or H is measured from the midpoint of the line joining the inner ankle bone. So, you have to be very, from the anatomy you need to understand what is the inner ankle bone, that protrusion in your ankle, right. So, that particular bone to a point projected on the floor directly below the midpoint of the hand grasp as defined by the larger middle knuckle of your hand. So, this one. So, from here. So, if you are holding your object, so this is your mid knuckle point. So, from here you have to go down on the floor, and that particular point and that the midpoint of your two ankle bone, you have to measure that distance. Okay. So, in situation where the H value cannot be measured, it can be approximated from the following equation. So, if you are not in a position to measure it exactly, then you can do such kind of approximation. Okay. So, for if you are using metric system, then you can use this formula. If you are using the pound or FPS unit, you can use this particular formula. Here W is equal to width of the container in the sagittal plane. So, width of the container. So, suppose you are holding a sack. Okay, so maybe sack is this side. So, that is the width of the, or if it is this, then width. Okay, and the V is the vertical location of your hand from the floor. So, that way you can measure it. It absolutely like depend, if you are not in a position to locate your ankle position, knuckle position, some cases working condition, sometimes it is difficult. So, for such cases you can use this formula. If you are using SI unit, you can use this formula if you are using FPS unit. So, for whole equation at the very beginning, you choose SI unit or FPS units. That is the recommended thing, because otherwise it will be mixed and you will not get the value. Okay. So, this is the horizontal component. So, I explained this particular figure earlier, that if this is the mid ankle point, then you connect it, you find the mid value, and here the knuckle point and connect it here. So, this is the horizontal location. Okay, and this is the vertical location. Fine. Now, under horizontal location, we have horizontal component, we have something more also to understand. So, if horizontal distance is less than 10 inches or 25 centimeter, then H is set to 10 inches. Okay. If it is less than 10 or 10, then it is 10. Okay, so you have to set it. So, any value less than 10, then you can ignore, you can get the value of 10. So, objects can be carried or held closer than 10 inches from the ankle, but in most cases the object cannot be lifted without encountering interference from the abdomen or hyperextending the shoulder. So it is not possible, no, you cannot be so close, then your abdomen is going to obstruct. So you cannot lift it like this, definitely it has to be like this. So that is why it is saying that 10 inches, that is the kind of human width that they are considering. So 25 inches, that is the 63 centimeter, is considered the maximum value for age. Also, if something you are lifting 25, so it's very difficult, if you are doing it, definitely you are going to bend it, right? You cannot lift anything in this way, it is not possible. Extending your shoulder till this and you are lifting, it is not possible. So anything beyond 25 inches is considered the maximum value for age as for short people, beyond which it is impossible to handle, particularly when lifting any asymmetric object. In addition to this, object at a distance more than 25 inches from the ankle normally cannot be lifted vertically without some loss of balance. So these are some from some practical positioning, these considerations need to be taken care. Now you may start inquiring things that where we are doing something more than that. Definitely those cases are little beyond of this type of calculation. Hypothetically, maybe we can have substitution, but when we do it in industry, definitely such hypothetical conditions is not possible to continue for some practical job. So these are the, so definitely if you get some measurement beyond these values, you will see that somewhere something is wrong. So you should recheck these values. Okay, so it is expected this should be within these ranges. So these are the guidelines where you can, if you get some data more than that, more than these values, you will see that somewhere some measurement mistakes are there, so you can rectify them. The horizontal multiplier is equal to 10 divided by h for h measured in inches and 25 divided by h if it is measured in centimeter. If h is less than or equal to 10 inches, then the multiplier is 1, and h, that horizontal multiplier value, decreases with an increase in the horizontal value. If horizontal value is increasing, horizontal multiplier value is decreasing. At h equals to 25 inches, then the multiplier is reduced to 0.4, and if h is greater than 25 inches, then multiplier is taken as the 0. Okay, so 0 means the whole value recommended weight limit is coming as 0. That means in such condition you cannot lift any object. Okay, so if any one of the multiplier among the all 6 variables, if any one of the multiplier becomes 0, that means in that condition you are not supposed to lift any object. Okay, so if the multiplier values are coming down, that means your recommended weight limit also is coming down. Fine. So that is the kind of inference that you have to draw. Okay, this is here. Now this is the horizontal multiplier table. So you can do the calculation, or you can use this pre-computed table. This is for inch and this is for centimeter. You have the multiplier table. So you can see if it is less than or equal to 10 inches, then value is 1. If it is more than 25 inches, the value is 0. Okay, if you are using inch, if you are using centimeter, if it is less than equal to 25, then it is value is 1, and if it is more than 63, then value is 0. Fine. So, this multiplier table also you can use. Next is vertical component. Horizontal component is clear. Now, we are going for the vertical component. So, vertical location or V is defined as the vertical height of the hands above the floor. So, here also we take reference of the mid knuckle point. So, V is measured vertically from the floor to the midpoint between the hand grasp of as defined by the large middle knuckle, and V is limited by the floor surface, and the upper limit of the vertical reach for lifting is 70 inches or 175 centimeter. So, that is the maximum possible lift. Okay. The vertical location should be measured at the origin and the destination of the lift to determine the vertical distance travel. So, for vertical distance travel, that is the D, for that you have to measure the vertical distance from the origin and the destination. So, this is this particular thing we described. So, this is your position of your object, this is the mid knuckle point, this is your surface location, and this particular height, this point you have to take it as the vertical location. Fine. Now, coming to the multiplier. To determine the vertical multiplier, the absolute value or deviation of V from an optimum height of 30 inches is calculated. A height of 30 inches above floor is considered knuckle height for a worker of average height. So, normally we take as the worker's average height is 165 centimeter. For them, the knuckle height should be 66 inches. So, that much only we can say for as the 30 inches. We take this particular value. So, Vm, that is the vertical multiplier, using this particular formula for V measured in inches and for centimeter, this formula we can use to measure in centimeter. If V is equal to 30 inches or 75 centimeter, then vertical multiplier becomes 1. The value of vertical multiplier decreases. Okay, value of vertical multiplier decreases nearly with an increase or decrease in height from knuckle height. If V is greater than 70 inches or 175 centimeter, then the multiplier, if you calculate this particular and or this, then it is approximately 0. Okay. So, as I said, if the vertical distance or vertical position or vertical location keep on increasing, then what is happening? We are taking some task which is nearly impossible to lift or lower. Okay. So, for those cases, vertical multiplier Vm is going to be nearly 0. Fine. So, this is the pre-computed table. If you are using inch, then this is, and if you are using centimeter, then it is. This is the part you can use. You can see if it is more than 70 inches, then multiplier is 0. If you are using centimeter, it's more than 175 centimeter, then also multiplier is 0. And as I mentioned, recommended weight limit is the multiplication of all these multipliers. So, any one of the multiplier, if it is 0, then recommended weight limit means that also becomes, the value becomes 0. That means it is impossible for someone to lift or lower any object in that particular condition. Now, distance component, that is the distance travel. What is the vertical distance travel? So, the vertical distance travel distance, that is the D, is defined as the vertical travel distance of the hands between the origin and destination of the lift or lower. Okay, here it is the absolute value. For lifting, D can be computed from the subtracting the vertical location at the origin from the origin of the lift from the corresponding V at the destination of the lift. For lowering task, D is equal to V at the origin minus V at the destination. So, D is assumed to be at least 10 inches. Here is again assumption, it need to be at least 10 inches and not greater than 70 inches. If it is more than 70 inches or near to 70 inches, again it becomes kind of 0. So, if the vertical distance is less than 10 inches, then D should be set at the minimum distance of 10 inches and 25 centimeter, like it is a corresponding value. So, distance multiplier you can calculate using this for D measured in inches and for this D measured in centimeter. For D less than 10 inches, it is assumed that 10 inch, it's the value, the multiplier value is 1. The distance multiplier decreases gradually with an increase in the travel distance. If the travel distance is increasing, so difference is increasing, the multiplier is decreasing. And it says that dm is 1 when D is set as 10 inches and when it is 10 inches, and when it is slowly increasing, then it becomes 0. So, we will take this value from this particular table. See, if it is more than 70 inches, then value is 0. If more than 175 centimeter, then again value is 0. So, you have to be very careful when you are doing this. So, you can use this table or you can use the earlier formula to get your distance multiplier. Okay, it is very similar. For each multiplier, the calculations are quite similar. You have to remember the formula. Now, asymmetry angle or asymmetry component. So, asymmetry refers to a lift that begins or ends outside the mid sagittal plane. If you are doing it in this mid range, then no problem. Okay, it's 1. Okay, multiplier is 1. Whereas if you are doing it this position or this position, so if your position initial position is this and you are lifting it here, so this particular angle, right? So if that angle increases, then again multiplier decreases. Similar concept. So, if asymmetry lifting cannot be avoided, however, the recommended weight limits are significantly less than those limits used for the symmetrical lifting. So, the asymmetry angle is not defined by the foot position or the angle of the torso twist, but by the location of the load relative to the worker's mid sagittal plane that we described earlier. The asymmetry angle must always be measured at the origin of the lift, and the angle A is limited to a range that is 0 to 135. It is not possible to go beyond 135. That is not possible for someone to lift any or lower any object. So, that is the maximum limit. So, from this I explained this particular figure. So, this is the asymmetry angle. So, again the measurement, how do we measure it? So, the asymmetry multiplier is 1 minus 0.0032 that particular angle. So, the asymmetry angle multiplier has a maximum value of 1 when the load is lifted directly in front of the body. So, that is the symmetrical position, and it is 0 when it is in maximum position, that is the 135 degree. Okay. If it is 135 degree or more than that, then the AM value becomes 0. If it is 0 means there is no movement, it is moving from here to here. So, you are in a mid sagittal plane, then the value is 1. So, this is the table that you can use. Then frequency. The frequency multiplier is defined by 3 ways: the number of lifts per minute, the amount of time engaged in the lifting activity, and the vertical height of the lift from the floor. So, lifting frequency refer to the average number of lifts made per minute as measured in 15 minutes time duration. So, your observation period is 15 minutes, you convert it into 1 minute lifting. If significant variation exists in the frequency of lifting over the course of that particular day, analysts should employ standard work sampling technique to obtain a representative work sample. So, it absolutely comes from your method, that how you are doing. So, if it is extremely different, or what you can do for this period and you can do for this period, if it is too much different. Okay. So, that way also you can segregate and you can do a proper sampling. So, lifting duration is classified into 3 categories: short, moderate and long, that I described, and this is the definition of these 3 things. So, short duration defines lifting tasks that have a work duration of 1 hour, followed by a recovery time which is equal to 1 times of the work time. Moderate defines lifting tasks that have a duration of more than 1 hour but not more than 2, followed by a recovery period of at least 0.3 times of the work time. And long duration defines lifting tasks that have a duration of between 2 to 8 hours with standard industrial rest allowances. Okay. So, this way you can define the lifting duration. These categories are based on the pattern of continuous work time and recovery period or recovery time. Okay. So, a continuous work time period is defined as a period of uninterrupted work. Recovery time is defined as the duration of light work activity following a period of continuous lifting. Lifting frequency, that is F, for repetitive lifting may range from 0.2 lifts per minute to a maximum frequency that is dependent on the vertical location of the object and the duration of lifting. The frequency multiplier value depends upon the average number of lifts per minute, that is the F, the vertical location of the hands on the origin and the duration of continuous lifting. So, these are the impacting factor. So, for lifting tasks with a frequency of less than 0.2 lifts per minute, set as the frequency equal to 0.2 lifts per minute. So, values for V are in inches, and for lifting less frequently than once per 5 minutes, that is the set is equal to F is equal to 0.2 lifts per minute. And this is the value. So, you can see you have three variety over here, that what is the duration. Based on that your frequency table will. So, you have 2 impacting factor, one is your hour and one is your vertical distance. Okay, so this you can use and you can get your frequency multiplier or frequency value. Now the last important factor, that is the coupling component or coupling factor. The nature of the hand to object coupling or gripping method can affect not only the maximum force of a worker can or must exert on the object, but also the vertical location of the hand during lifting. So if it is very heavy, automatically the vertical location decreases, right, because it is pulling down. So a good coupling will reduce the maximum grasp force required and increase the acceptable weight of the lifting. A poor coupling will generally require higher maximum grasp forces and decreases the acceptable weight for the lifting. The effectiveness of the coupling is not static. Effectiveness is not static, but may vary with the distance of the object from the ground. So the entire range of lift should be considered when classifying the hand-to-hand object coupling. Very important. If you are not talking about hand-to-hand coupling, then you will not be able to define it properly. Here experience comes, skill, how to analyze it, that is very important. The analyst must classify the coupling as good, fair and poor, and this is the kind of definition that you can follow for your coupling, hand to container coupling classification. What is good, what is fair and what is poor, it is clearly defined. Okay, so you can use this particular definition. And how do you take decision for the coupling quality? So it's a kind of guideline, it's a kind of guideline that you can use. So if it is a container or if it is a loose object, if it is a container you can take this path, and if it is a loose object then you can take this path. So if optimal container, non-optimal, if optimal then optimal handle, non-optimal. So that way you can get the result, good, fair and poor. Here also if it is loose object then also you get an understanding of good, fair and poor. So this is a very good guideline that you can use, and this guideline you can use maybe for other tool also where it is not defined properly or you are a learner. So this is not only for NIOSH lifting equation, this particular guideline for understanding the coupling quality you can take for the other tool where it is not defined. So coupling factor, now here again coupling factor is connected with your vertical vertical distance, right? So that's a V component. So if it is less than 30 inches, if it is it is good, then this is value is 1. If it is poor, then the value is 0.9. So this way you, based on your vertical distance, the coupling factor also changes. Okay, now this is the job analysis worksheet. Of course, it is being referred from the actual publication. So what you can do, you can give the all description over here, and you can have all the variables measured over here, and from once you do that, go back to the multiplier, the formula or the table, get all the recommended weight limit for origin separately, for destination also separately. Okay, and then you can do the calculation of your lifting index, actual weight divided by recommended weight limit. We are coming next for your example. So this is an example where these values are given. Okay, these values are given, it is being explained here. So I'll just read the example. Consider a worker inspecting compact containers for damage on a low shelf and then lifting them with both hands directly in front of the body, okay. So that means there will be no asymmetry angle. So it is here, it is getting lowered. So directly in front of the body from a shelf 1 to shelf 2 at a rate of 3 per minute for a duration of 45 minutes. For this analysis, assume that the worker cannot take a step forward when placing the object at the destination due to the position of the bottom shelf, and the significant control of the object is required at the destination, because what is happening, you have to position it very carefully, it may fall then. The containers are optimal or are of optimal design but without any handle. So these are the things given, okay. From this explanation you got all these L lifting constant, then your V, A, C, duration, hand like H, D and F, okay. All these things you got. So what you do, you go for the values. So you calculate over here H, then what is horizontal multiplier, V, then what is vertical multiplier. Here I will tell you something. So from the formula you got a value of 0.94, right. So if you don't go by formula, suppose you are taking this particular table, then maybe you can take this value, because this is also a value, this is also a value, okay. So you can go for this, okay. Now for D, then I should say, so you are doing it in front your body, so there is no asymmetry multiplier, because it is not asymmetry multiplier, there is no asymmetry angle. So asymmetry angle is 0, that is why the value of asymmetry multiplier is 1, okay. Then F, V, and from all these things you get this value, and for coupling also you get this multiplier value. Now once you do this, so at origin you put all these things, so they are doing it pound, so that is why 51 pound, and here also load constant is 51 pound. So at origin the weight limit is 34.9 pound, and at the destination it is 15.2 pound, right. So at origin the value becomes 0.8, whereas at destination the value is 1.7, okay. So we need to take a decision that how do we do the changes, so that the whole process becomes safe for that particular person while doing this job, to know how we can do the changes, so that there is no risk for low back pain. So here it is not a concern, whereas here it is a concern. So definitely we need to check which is the component is causing the more problem, right. So if you see, this is 0.5, this is 0.78, 8.87, 1 definitely there is no problem. This is also quite close to close to 1, this is also quite close to 1. Here these are the two factors which may cause problem. Among that, this is the main problem, because it says 0.5, so it is causing the lowering the recommended weight limit. So for destination you need to check how you can work on the horizontal value, horizontal distance, okay, horizontal location. Then so the positioning of the positioning of your this particular destination. So from that you may have some kind of calculation or redesigning of your alignment, redesigning of the whole workplace may enhance this particular value, and which will reduce this value and which will come near to 1. Okay, maybe not exactly 1 but near to 1. Okay, then only your intervention is successful. So here no intervention is required, however you need an intervention over here. Okay, so you need to see how you can do the design changes at the destination place, so that the values are changing. Okay, so that this is how we use the recommended weight limit and lifting index for our analysis. Good. So this is the whole process. Now let us go for the advantage and disadvantage. So first is advantage, improves the awareness of the worker. So you are aware, it's not only the analyst who is doing the job is aware, okay, the worker who is working, he or she is also aware. Okay, improves the awareness of the workers about their respective job tasks. It helps as a job design guidelines for developing and redesigning a manual lifting task, and also it is used for estimation of the relative magnitude of the physical stress for a given task. It is a relative magnitude, it is not the exact value. Okay. However, it has some disadvantages. It cannot assess the physical stress on the one-handed manual lifting task. You need both hands to work. It is not applicable for the activities like holding, pushing, pulling, carrying, walking and climbing, only lifting and lowering. Okay. It does not include factors to account for unpredicted conditions such as unexpectedly heavy load, slips or fall. You cannot describe it over here. It was not designed to assess the task involving one-handed lifting, lifting while seated, kneeling or lifting in a constrained or restricted workplace. For such cases, this tool is not useful. In a very standard case, this tool is only useful. So these are the disadvantages of this particular equation. So these limitations, this revised NIOSH lifting equation does not apply if any one of these following condition occurs. So lifting lowering with one hand, lifting lowering more than 8 hours, so you will not be able to describe it, while seated or kneeling, so I am repeating the same thing, in a restricted workplace, unstable object, the object if it is unstable, carrying, pulling, pushing you cannot explain, wheelbarrows or shovels you cannot explain, high speed motion you cannot explain, unreasonable foot or floor coupling, so there also you will not be able to explain, and in an unfavorable favorable environment, like temperature is significantly outside the zone. So if it is extreme cold or it is extreme hot, those cases this lifting equation may not work. So before you start using this particular tool for analyzing your task, please check these list of limitation. Okay, if it is not following under any such condition, then definitely you can use it. So that's all for NIOSH lifting equation. It is very useful tool. So I suggest you take an example whatever is available in your nearby location or your nearby research area, and practice it, because you know initial days understanding those points and a position are very important. If you do not understand those positions, you will not be able to get the correct measured value. Okay, that's all for Niosh lifting equation. We will take up some other tool in our next class. Thank you.